Remote desktop is how many admins actually manage Windows servers day to day. But those constant certificate warnings? They train people to click through security. In this topic, we'll use your enterprise PKI to give RDP trusted TLS, cleaner logons, and stronger encrypted administration. Up to this point, you've built a complete PKI story. You understand cryptography and trust. You stood up an Azure lab with Active Directory, and you deployed AD CS with working templates and revocation. Now we'll reuse that same infrastructure to give remote desktop sessions strong server identity and encrypted connections. Remote desktop already uses TLS to encrypt the session, but encryption alone isn't enough. You still need confidence that you're talking to the right server. That's where RDP certificates come in. A trusted certificate proves the server's identity. When certificates are untrusted or wrong, people get used to ignoring warnings, which quietly normalizes risky, potentially compromised connections. When you just enable remote desktop and stop there, Windows quietly creates a self-signed certificate. It encrypts traffic, but it doesn't prove who the server really is. There's no enterprise CA behind it, so the certificate chain can't be validated and clients show warnings. On top of that, the certificate name often doesn't match the DNS name admins use, which creates even more distrust and encourages users to click through security prompts. Those RDP certificate warnings usually fall into a few patterns. If the certificate isn't from a trusted authority, you're likely using a self-signed or internal CA that the client doesn't know about, so you deploy that CA certificate to the client. Name mismatch errors come from connecting with a hostname or IP that doesn't match what's on the certificate. Expired warnings are just lifecycle issues. Renew, replace, and redeploy the certificate. For RDP, not every TLS certificate will do. It must include the server authentication EKU, so clients recognize it as a server identity. The subject or SAN has to match the DNS name user's type, usually the server's FQDN. The private key needs to be present and usable on that specific server. And the certificate must live in the local computer personal store, so remote desktop can find and use it. When you open an RDP session, the client effectively asks one question. Does the name I'm connecting to appear in this certificate's SAN list? For a smooth, warning-free experience, make that answer yes every time. Put the server's FQDN in the SAN and standardize on that FQDN as the connection name. Only add NetBIOS names or IP addresses if they're truly needed and allowed. Fewer names mean fewer warnings and more predictable security. Designing an RDP certificate template starts with purpose. Ensure it includes the server authentication EKU so it's valid for TLS. Then get naming right. Let the subject and SAN be built from the server's DNS information so clients can reliably match certificates to hosts. Next, lock down who can enroll. Limit enrollment or auto-enrollment to known RDP server groups. Finally, review renewal settings so certificates rotate before expiry and you avoid last-minute surprises. Choosing how to enroll RDP certificates is about scale and consistency. Manual enrollment works for a handful of lab or test servers. You touch each machine, so you get very tight control, but it doesn't scale and renewals become a tracking problem. Auto-enrollment via group policy is ideal in a domain. Templates, group-based permissions, and automatic renewals give you predictable, repeatable deployments across many servers. For remote desktop to present a certificate, two conditions must be met. First, the certificate has to reside in the local computer's personal store, not just in a user store. Remote desktop runs as a service, so it can't see user-only certificates. Second, the certificate must include an accessible private key. If the private key is missing, or permissions block the RDS service account, TLS negotiation fails and clients can't connect. Once your CA is issuing the right certificate, you still need RDP to actually use it. In a domain, you handle this with group policy. Configure the remote desktop session host security policy to reference the certificate template name. When the policy applies, each server searches its local computer personal store for a certificate from that template that meets RDP requirements. If it finds one, that's what clients see, instead of a random or self-signed certificate. You can think of this as a three-step pipeline. First, use certificate auto-enrollment, so every domain server automatically receives a valid server certificate without manual requests. Next, point remote desktop session host to the correct certificate template so RDP actually uses those certificates. Finally, lock down the connection. Enforce TLS or SSL as the security layer and require network-level authentication, so users are verified before a full RDP session is established. When a user starts an RDP session, the client silently runs a series of trust checks. It begins by asking, "Do I trust the issuing root CA?" Domain join machines usually do. Standalone machines might not until you import that root. Then it verifies the chain, checks revocation, and confirms the server name exactly matches what's on the certificate. Only when all of those pass do users get a clean, warning-free connection. After deployment, always test by connecting with the exact DNS name listed in the certificate's SAN. If you see a warning, open the certificate and verify the EKU, expiration date, and that a private key exists. Next, walk the trust chain, root, intermediates, and CRL or OCSP reachability. Use MMC and certutil to inspect server certificates, event viewer for channel or RDP errors, and group policy results to confirm the right template and settings apply. You've seen that self-signed RDP certificates encrypt traffic, but don't provide strong domain-level trust. By issuing proper server auth certificates, matching DNS names, and enforcing settings with group policy, you get predictable, secure RDP. In the next module, we'll extend these concepts to user and computer certificates, renewal, revocation, and CA recovery.